this problem, you need to show how these two reagents react and decide whether it's an SN1 mechanism or an SN2 mechanism. In the products, you have to show a specific stereochemistry if it exists. So the first step you need to take is to identify what kind of halide it is. So this is a primary halide, meaning that it's only going to react by an SN2 mechanism. This is also a strong nucleophile, but since it's primary alkyl halide, it's going to react by an SN2 anyway. So it attacks in a concerted step, attacking the carbon and kicking out the leaving group in the same step. And our product is this. If this were a stereocenter, it would invert the stereochemistry, but it's not, so we don't have to worry about that in part A. In part B, our reagents are that and the azide anion. So once again, you identify what kind of alkyl halide it is, and this is secondary, so it can do SN1 or SN2. So then you look at the nucleophile, and it's a strong nucleophile. So instead of favoring SN1, it favors SN2. So once again, it attacks in a concerted fashion, attacking and kicking out the leaving group in the same step. And SN2 reactions invert the stereochemistry where it was attacked. So you get this product. And just make sure to pay attention to the stereochemistry there. In C, our reagents are this and this. So once again, you identify what kind of alkyl halide it is. This one is tertiary, so it can only react via an SN1 mechanism. The nucleophile is also weak, which favors SN1, but it's going to react via an SN1 anyway because it's a tertiary halide. So the first step in an SN1 reaction is heterolysis. So the leaving group leaves by itself. And then the nucleophile attacks it, both frontward and backward attack. But since there's no stereocenter here, it forms one product. And the last step is a proton transfer between the substrate and another molecule of the solvent, or nucleophile in this case. That's consistent with the leveling effect because the strongest acid that can exist in a solution is the protonated solvent. So our final product for this one is this and the protonated solvent. For D, our reactant is this. And our nucleophile is water. Okay, so once again, you identify the alkyl halide. This alkyl halide is also tertiary, so it can only react by an SN1. The nucleophile being weak also favors an SN1 reaction. So in the first step, the leaving group leaves. And it produces a planar carbocation. And in the next step, the nucleophile attacks from front side and back side. So it forms this. Plus it's an enantiomer. An enantiomer just means that the wedge and the dash are switched. And in the last step, another proton transfer occurs between the product and the solvent. So our final product keep in mind that you get about an equal mixture of both this and its enantiomer. Because it was an SN1 reaction. So you get a racemic mixture of products.